Today we're going to talk about properties of transformations. To begin with, let's review. We've talked about congruency. If a transformation produces an image with the same size and shape as the pre-image, the figures are congruent. Now the symbol for congruency is the equal sign with the tilde above it. This little symbol here is called a tilde. And we can use that to create congruency statements. So we can say triangle ABC is congruent to triangle A prime, B prime, C prime. If you don't want to start with A, you can start with a different letter, like triangle BCA is congruent to triangle B prime, C prime, A prime. The order doesn't matter so long as they match. So the letters, the vertices, must match the same order. Now, when a transformation creates a congruent image, we call that transformation a rigid transformation. And so far we have learned three rigid transformations. They are translations or moves, slides, reflections, mirrors, flips, and rotations, spins, and turns. All three of these will create images that are the same size and shape as their pre-image. And then we have similarity. If a transformation produces an image with proportional sides and congruent angles, then the figures are similar. The symbol for similarity is just the tilde sign. And just like congruence, we can use that to create similarity statements. Triangle CAB is similar to triangle C prime, A prime, B prime. Again, the only thing that matters is that the vertices are in the same order, so you could say triangle CBA is similar to triangle C prime, B prime, A prime. So just make sure that the vertices go in the same order. The only transformation that we've learned that produces similar figures is a dilation. So that covers all four of the transformations that we have learned. So let's take a look. Let's take a look at applying what we know. In this figure, we have triangle ABC and triangle A prime, B prime, C prime. Now, the first thing I noticed as I was tracing that is that with the pre-image, I was going around clockwise. And with the image, I'm going around counterclockwise. The only transformation that does that is a reflection. Also, notice that A and A prime are at a different distance away from each other than C and C prime. That wouldn't happen with a translation. So, in conclusion, so therefore, triangle ABC was reflected over the y-axis. What do we notice about the corresponding side lengths and angles? Oh my gosh, because the figures are congruent, the corresponding side lengths and angles are the same. Wow, the same size. So again, reflections produce congruent figures. So triangle ABC is congruent to triangle A prime, B prime, C prime. Ooh, look, this appears to be something other than congruent figures. So we have triangle ABC down here in the middle, and then it's expanded outward. So if the pre-image is smaller than the image, we must have had a dilation. Now the question is, what is the scale factor? Well, segment AC is 1, 2 long. Segment A prime C prime is 1, 2, 3, 4, 5, 6. So 2 times 3 is 6. Let's do that a different way. 6 divided by 2 is 3. So triangle ABC was dilated by a scale factor of 3. Ooh, corresponding lengths and angles. Well, the corresponding angles are still congruent. They're still the same size, but the corresponding sides are proportional. The sides of the image are 3 times as long as the sides of the pre-image. That must mean that it's similar. So triangle ABC is similar to triangle A prime, B prime, C prime. Or in this case, triangle CBA is similar to triangle C prime, B prime, A prime. All right. Now we can also transform a figure using a sequence of transformations. That's when more than one transformation is performed. So we are going to start apparently by reflecting triangle XYZ over the y-axis. To do that, we probably need to begin with some coordinates. So the coordinates of x are -10, -10. Coordinates of y are -6, -3. And the coordinates of z are -2, -10. So knowing that, we can now use the rule to reflect a figure over the y-axis, which entails changing the sign on the x-coordinate. So -10 will become +10, -6 will become +6, and -2 will become +2. And voila, x prime will be 10, -10, y prime will be 6, -3, and z prime will be 2, -10. And then we can quickly graph those, x prime, y prime, and z prime. And lo and behold, we get this pretty little triangle. All right, now we're going to take that image as, now we're going to use that image as a pre-image and translate it up 12 units. Translate it up 12 units. And so the rule for that is to simply take and add y to, and add 12 to the y coordinate. So -10, and then -10 plus 12 is +2. 6, -3 plus 12 is 9, and 2, 2. So we can graph those really quick. X double prime, Y double prime, and Z double prime, giving us this beautiful little triangle that looks, oh my gosh, just like the other two. Because reflections and translations are rigid transformations, all the triangles are congruent. So triangle XYZ is congruent to triangle X prime, X double prime, Y double prime, Z double prime. All right, now Josephine. She thinks that she can get triangle X double prime, Y double prime, Z double prime by translating the triangle 12 units to the right. So in other words, she'll take this triangle and translate it 12 units to the right, and then 12 units up. Okay, again, she's translating twice, and translations are rigid transformations, so the triangles would indeed be congruent. Here's the thing. Our first transformation was a reflection. So notice that X, Y, Z, we're going around clockwise, aren't we? And after the reflection, we have X prime, Y prime, Z prime. We're going around counterclockwise. So although the triangle Josephine creates will be congruent, reflections change the orientation of the vertices. So the triangle that Josephine creates won't have the same orientation. Okay, so so the triangles will actually be different. They'll be congruent, but different. Ooh, now we get to analyze. We have triangle DEF here, and somehow it has been transformed twice to get to triangle D double prime, E double prime, F double prime. So so how did this happen? There are actually two possibilities. Let's deal with possibility one first. Possibility one says that we can translate triangle DEF 8 units to the left. So I'm going to take this triangle and translate it 8 units to the left. So we will be right here. Okay, so we will have transferred triangle DEF to this spot right here. And then we will reflect it over the x-axis. So we'll take it and flip it over the x-axis. So the D comes to D double prime, the E prime comes to E double prime, and the F prime comes to F double prime. So that's one way to do it. Here's another. What if we start with the reflection? We'll reflect triangle DEF over the x-axis. So we'll go from here. Point D will come down to D prime right here. Point E will come down to E prime right here. And point F will come down to F prime right here. So we will have a little triangle that's upside down here. And then we will translate it 8 units to the left. So take the triangle that's right here and shift it 8 units to the left. Oh my gosh. Because reflections and translations are rigid transformations, you can interchange the order and you'll still end up with congruent figures. Triangle DEF is congruent to triangle D double prime, E double prime, F double prime. Ooh, this one was not a rigid transformation, right? Triangle PQ, or triangle? Rectangle PQRS is much smaller than triangle P double prime, Q double prime, R double prime, S double prime. And I just said triangle again. They're rectangles, aren't they? So what are we going to do here? Well, first thing that we need to do is we need to dilate PQRS. What is the scale factor, you ask? 3. How did I find that? Well, let's actually look at PQ. Segment PQ is 2 units in length. Segment P double prime, Q double prime is 6 units in length. 6 divided by 2 is 3. So now that we have it dilated, when we get it dilated, it's going to be right here. It's going to be this distance right here. Okay? So it's going to dilate straight out from the origin. Okay? So come straight out from the origin. So we'll get this figure right here. All right. And then we are going to take that and we will translate it to the right 5 units. So we'll come from here over to here 5 units. We'll come from here over to here 5 units. Everything will be shifted 5 units to the right. And of course, because it's a dilation, it's similar. PQRS is similar to P double prime, Q double prime, R double prime, S double prime. Now, because we are dilating, and dilations always occur around the origin, we cannot interchange these two transformations. We cannot change them. The dilation must come first. Okay? Ooh, finally, triangle VWX is contained in quadrant 1. If VWX is rotated 180 degrees clockwise, then reflected over the y-axis, answer each of the following questions. So we're starting up here with triangle VWX. Okay, and we are going to rotate it around 180 degrees, which means that we have rotated it around down over here. And we have VWX. And now we're going to flip that over the y-axis. So it'll come over here. So we have VWX. And in reality, these should be primes and these should be double primes, right? Well, geez, I think we answered our question there. So when VWX is rotated 180 degrees, it rotates around 2 quadrants into quadrant 3. And then when we reflect it over the y-axis, it's reflected into quadrant 4. Therefore, the final image will be in quadrant 4. Now, will the figures be similar or congruent? A rotation is a rigid transformation. A reflection is a rigid transformation. All rigid transformations produce congruent figures. So therefore, triangle VWX will be congruent to triangle V double prime, W double prime, X double prime. Well done.